Okay, so in this part of quadratic functions, we're going to be finding the vertex. Now, there are two forms of a quadratic function which you're going to be involved with. The first one is called standard form, and the other one is called general form. Now, your book uses the word standard form for what we're about to look at. Your book does not use the word general form. We're just going to call what you're about to see general form. All right, so notice when we looked at the previous lesson, remember the functions that we're graphing look like this. So you had some binomial squared and then a constant. Some binomial squared and a constant. So notice all this. A binomial squared and a constant. A binomial squared and a constant. So notice I'm saying binomial. A binomial squared plus a constant. A binomial squared plus a constant. All right, so that, and we only did 6 in that section. So when we talked about that, one of the pages we looked at was this form right here. We said that this was the standard form of a quadratic function. And then we also said that it's sometimes called the vertex form. And so notice that all of these functions that we graphed in the previous section were of this form, some binomial squared and a constant. All right, now remember this is called standard form, not general form, standard form. It is also called vertex form. All right, but your book uses the word standard form. And the reason it's called vertex form is because whenever it looks like this, a binomial squared and a constant, you can easily, very easily get the vertex from it. All right, so notice that when we graphed this one right here that was in standard form, look at the vertex. The vertex was -1, 2. So remember, here it is right here. -1, -2. You see this -2 right here, that constant? That's the y-coordinate of your vertex. And you see this binomial, and you wonder, well, why? This says x plus 1, but you have -1. Well, that's because in the standard form, the standard form looks like this. If I can find it now. The standard form is x minus h squared. This is x plus 1 squared. So you have to rewrite it as x minus a -1 to get that h. Okay? So we can talk about that. All right, so let's go back to this page, if I can get to it. Okay, so standard form looks like this. F of x equals a times x minus h squared plus k. And then the general form is just ax squared plus bx plus c, just your quadratic form. Okay? Now, your vertex, remember, just want to find the vertex. If it's in standard form, the vertex is just h comma k. That's all it is. Now, remember, though, when you write h, it's got to be x minus h, and then that h is the x-coordinate. So when you talked about this right here in a previous lesson, see the vertex was not, this is the vertex right here, the vertex was not 1, -2, because this has to be of the form x minus a -1. So your vertex, the x-coordinate vertex is -1. Okay, so when we do this, when you find the vertex, just in your mind, if this says x plus a number, you're going to think in your mind, well, I've got to rewrite as x minus a number, and that number is is the x-coordinate of your vertex. All right, so just keep that in mind. Now, we're going to do this in first, and then we're going to come back to this, and then we're going to talk about this right here. So let's just for right now, find the vertex of functions, of quadratic functions that are written in standard form. Okay, standard form. All right, so here's the first one. Number 1, so you want to find the vertex of each quadratic function. All right, so find the vertex of each quadratic function. All right, so number 1, let's suppose that f of x is equal to -2 times x minus 3 squared plus 5. So -2 times x minus 3 squared plus 5. Now remember, in your mind, you're thinking this. You're thinking, All right, it's this is in standard form or vertex form, so I know that this is the a times x minus h squared plus k. All right, so if you think about it that way, so see how it's already written as x minus, so h is 3, and then plus 5 plus k, and so k is a positive 5. So k is a positive 5. So your vertex is 3 comma 5. That's the vertex of this quadratic function that's written in standard form. And it's quadratic because if you were to FOIL this out, x times x is x squared. So you get x squared. That will be your largest exponent. All right, number 2. I suppose we had g of x equal 3 times x minus 2 squared minus 7. Let's suppose you had that. All right, so if you got to think about it, do the same thing. You'll say a times x minus h squared plus k. All right. So see, it's already x minus, so that's a good thing. So h is 2. Now, common mistake people make is that they see x minus 3 and they think that the vertex is a negative 3 for the x coordinate, and it's not. It's 3 because the form says x minus h. X minus h. All right, so x minus 3. So h is 3. All right, so you got to be careful. So your vertex here, oh, and also k would be the negative 7. Okay, k is negative 7. So your vertex is hk. So h represents the x coordinate of your vertex, so that's 2. K represents the y coordinate of your vertex, so that's negative 7. All right, number 3. Suppose h of x is x plus 3 squared plus 4. X plus 3 squared plus 4. All right, so again, we have a times x minus h squared plus k. Okay, that's the form. That's a vertex or the standard form. All right, so notice though that a is 1. That's going to be important at some point. A is 1. All right, now see right here where in the previous two you had x minus, x minus, x minus, x minus. Here you don't. You have x plus. But remember though, x plus a negative 3 is the same thing as saying x minus a negative 3. So it's important that you think of it that way as well. X minus a negative 3. So right away, h is negative 3. All right, so x minus, so h is negative 3. And then k is 4. The vertex, negative 3 comma 4. That's your vertex. Number 4, f of x equal 2, negative 2, times x plus 5 squared minus 2, let's say. All right, so again, think of it as a times x minus h squared plus k. All right, the issue is that this is x plus and this is x minus, so you got to rewrite, or not rewrite it, but you can if you want to, but you got to think about the form. So I know that the vertex form or the standard form says x minus, and this would be x minus a negative 5, because x minus a negative 5 is x plus 5. And so right from there, see x minus, so that means that h then is a negative 5. And then k then is a negative 2. So your vertex, negative 5 comma negative 2. All right, so you got to be careful. So don't say 5 negative 2. Don't say 3 negative 3 4. Remember, it's x minus. So you got to think x minus a negative 3, x minus a negative 5. All right, so remember the form, x minus h squared. All right, and then 5. Let's do one more with the standard form. Suppose we had f of x equal 1/2 times x plus 7 squared plus 2, let's say. All right, so x plus 7 squared. So remember the vertex form, the standard form, a times x minus h squared plus k. So think of it like that. And in your mind, you're saying, all right, so x minus h, where h would be the x coordinate vertex, but this says x plus 7. But I do know from a previous course that x plus 7 means the same thing as x minus a negative 7. And so right away, I know that h is a negative 7. And then k is a positive 2. So your vertex would be negative 7, comma 2. All right, so once it's written in standard form, you can easily find the vertex. Now, let's look at this one real quick. Number 6. Let's look at number 6. Suppose h of x is negative 2 times x plus 4 squared. All right, suppose it's just that. All right, well, so remember, a times x minus h squared plus k. All right, so in your mind, this is what you're thinking of. So this is x plus rather than x minus. But I do know that x plus 4 is the same thing as saying x minus a negative 4. Okay, and so this is your h right here. So negative 4 is your h. And you might say, well, what is k? Well, remember though, that right here is the same thing. See, there's no constant listed, but it's understood to be a 0. All right, so don't forget that's plus 0. So k is 0. That's what the y-coordinate of your vertex is. So your vertex then is negative 4, comma 0. That's your vertex, which happens to be on the x-axis. Okay, so don't forget that there's no constant there, so it's going to be 0, so that's your k. All right, so number 7, suppose we had f of x equal x minus 4 squared, because that was it. So in your mind, you're thinking, all right, well, I know that the form needs to be a times x minus h squared plus k, and this is already x minus, so right away I know that h has to be 4, positive 4, and there's no constant listed here, but it's understood to be 0, so k has to be 0. So your vertex is 4, comma 0. All right, so that takes care of the standard form. So the standard form is fairly easy. You can easily determine the vertex because in the vertex form, or the standard form, is the hk, is the x-coordinate vertex and the y-coordinate vertex. All right, now let's look at this one right here. So let's talk about this, general form. So your equation will either be given in standard form or general form. If it's standard form, it's easy to determine the vertex. If it's in general form, it's not so easy to determine the vertex. So there's a formula you can use. Let's talk about that formula. Now the derivation of the formula involves completing the square. The derivation of the formula for finding the vertex involves completing the square. All right, so that is in one of the lessons on Canvas, but it's not required that you regurgitate that for the test or the final. You won't be asked to complete the square in this general equation to get the vertex formula. All right, but if you're interested in seeing how the formula for finding the vertex comes about, then go to that lesson. Okay, so it's on finding the vertex formula. Okay, so let's go and determine how to, or what is the vertex formula when the general equation is given. See, you don't need to know the vertex formula here. Why is it you don't need to know the vertex formula to do this one? Well, because it's already in vertex form. This is h, this is k. Voila, you have it. No formula was needed. You just needed to know what the equation looked like. Here, there is a formula that you have to use. So let's talk about that. All right, so let me write the journal form again. So here's the journal form. All right, so f of x equal ax squared plus bx plus c. And so the vertex of the parabola, remember the shape of a quadratic function is a parabola, can be found or is defined. So the vertex of the parabola is given by, all right, so here's the formula. Now remember, the vertex is a point. All right, so we're going to have a point here. So there's going to be an x-coordinate and a y-coordinate. Notice I'm leaving some space here. So there's an x-coordinate and a y-coordinate. Now the x-coordinate is found this way. All right, so here's the x-coordinate of the vertex. Negative b divided by 2a. Negative b divided by 2a. That's the x-coordinate of the vertex. Now, guys, once you find the x-coordinate, think about what you do to find the y-coordinate. So let's go back and review something we've done before. Suppose your function f of x is given by this function, 2x squared minus 3x plus 1. Okay? And you want to find f of 3, let's say. Now remember f of x means the same thing as y. So this right here says when x is 3, find out what y is. So when x is 3, find out y. So if x is 3, how do you find your y value? Well, all you do is plug 3 back into here, because that's what this says. This is going to be your, x is 3, but the whole thing would be your y coordinate. So to find the y value, all you do is you find f of 3. That's all you do. And so f of 3, then, wherever you see the variable x, you plug in 3. And so we're going to get 2 times 3 squared minus 3 times 3 plus 1. 3 squared is 9. 9 times 2 is 18. Minus, and then 9 plus 1. This is 9 right here. 9 plus 1 is 10. So f of 3 is 10. That's what you found. So taking this idea with this, okay, so remember, if x is 3, your y coordinate is going to be f of 3, okay, which happened to be 10. If x is negative b over 2a, then your y coordinate is going to be f of negative b over 2a. So basically it's just saying this. Whatever your x coordinate is, you substitute to find your y coordinate. So you take negative b over 2a and plug it back into x in your function. Okay? So that's a vertex of the quadratic function. All right, so let's look at an example. Okay, so let's go here. So let's call this number 6. So again, we're still finding the vertex, except this time it's going to be in general form. Number 8. Okay, suppose number 8 was this. Suppose you're told that f of x is 2x squared minus 8x plus 3. So 2x squared minus 8x plus 3. Okay? All right, and then, okay, so then you remember you want to find the vertex. All you want to do is find the vertex. So remember the x-coordinate of your vertex, the x-coordinate is this right here. That's negative b over 2a. So all you got to do, just like you did when you found the quadratic, when you used the quadratic formula to solve the quadratic equation, you label what a, b, and c are. So a is 2, b is negative 8, and c is 3. Now in this case, the c is not needed for the x-coordinate vertex. You just need a and b. So a is 2 and b is negative 8. So then we plug it back in. So the x-coordinate is going to be the opposite of b. If b is negative 8, the opposite of b is a positive 8 over 2 times a. A is 2. So that's 8 over 4, which is 2. So what I found so far was that the x-coordinate of my vertex is 2. And then to find the y-coordinate, to find y, you're going to say f of 2. That's your y. So where we see the variable x, you're going to plug in 2. And so I get f of 2 then would be 2 times 2 squared minus 8 times 2 plus 3. And so using the order of operations, 2 squared is 4. 4 times 2 is 8. Negative 8 times 2 is negative 16 plus 3. And then that's a negative 8 and then plus 3, which is a negative 5. So my vertex, this is your vertex right here. So my vertex is 2, negative 5. So again, this is what we did. Your x-coordinate is negative b over 2a. Okay, that's the x-coordinate of your vertex. So you got to label your letters. So a is 2. Remember, a is the coefficient of x squared. B is a coefficient of x, so be careful, this is negative 8, not 8, negative 8, and c is your constant. So the x-coordinate would be the opposite of b, so if b is negative 8, the opposite of negative 8 is positive 8, divided by 2a, so that's 2 times a, which is 2, so that's going to be 4. 8 divided by 4 is 2, so that's the x-coordinate of your vertex, that's what you found. To find the y-coordinate, you're going to plug 2 back into your function, so basically you're finding f of 2. And so where you see your variable x, you're going to plug in 2. And so that's where you get the y-coordinate to be negative 5. So it's a good idea to work your problems out this way, step by step, just like we did. Okay. Now, so all they wanted to do was to find the vertex. Now, in this little part here that we're doing, the vertex can be some nice numbers. In other words, x and y will be integers. It is possible if you have fractions. I mean, you could have a vertex that's a fraction. But in this section, your vertex will be integers. So x can be an integer, y can be an integer. Okay, so let's look at number 9. All right, number 9. Suppose we had this. All right, suppose we had f of x is negative x squared minus 2x plus 8. All right, suppose we had that. All right, now remember, this is general form, so a is the coefficient of x squared, so that's a negative 1. Make sure you understand that's going to be negative 1. B is the coefficient of x, so that's negative 2. So a is the coefficient of x squared, so that's negative 1. B is the coefficient of x, so that's negative 2, and c is your constant. Now in the formula for finding the x-coordinate of your vertex, that c was not really needed. Now you need the constant when you plug that x-coordinate back in, but in terms of the formula for negative b over for the x-coordinate of your vertex, negative b over 2a, c is not needed. So you just need this, a and b. Okay, so the x-coordinate of your vertex, x-coordinate will be negative b over 2a. All right, so let's substitute this in. So x is going to equal, okay, so this says I take the opposite of b. So b is a negative 2. The opposite of a negative 2 is a positive 2. And then the denominator is 2 times a. A is negative 1. So I get 2 divided by negative 2, which is a negative 1. So the x-coordinate of your vertex is negative 1. Now to find the y-coordinate, you just take negative 1, and wherever you see the variable x, you plug in negative 1. But remember, the y-coordinate, you're really finding f of negative 1. That's what you're finding. So f of negative 1. So you go to your function, wherever you see the variable x, you plug in negative 1. Now remember, make sure you put all that in parentheses. So you got to be careful. This is, if you're going to mess up, it's probably going to be around here. So if you need to, say this is negative 1 times x squared. Negative 1, this one's going to be negative 1, times x squared. And then in place of x, I'm substituting negative 1. Oops, negative 1. And then minus 2 times x, which is negative 1, and then plus 8. So negative 1 times negative 1 squared minus 2 times negative 1 plus 8. And so negative 1 squared means negative 1 times itself, so that's a positive 1. A positive 1 times a negative 1 is a negative 1. A negative 2 times a negative 1 is a positive 2, and then plus 8. That's a positive 1 plus 8, which is 9. So your vertex is negative 1, 9. That's your vertex. All right. Now, before we go any further, let's kind of talk about something else that we talked about in the previous lesson. Remember A is 2. Remember we said that if A is positive, what happens to the graph of the parabola? Do you remember we said? So we said that if A is positive, the parabola opens up. If A is negative, which it is here, the coefficient of x squared is negative. That's what you're looking at. If A is negative, the parabola opens down. All right? So keep that in mind as we go through the next lesson. All right, let's look at number 10. Suppose you had f of x equal x squared minus 6x minus 2. Okay? It's really not that difficult. You just got to know a, b, and c, or a and b rather, and then know your formula for vertex. All right, so a is 1, coefficient of x squared is 1. B is negative 6, and c is negative 2. Okay? So remember, your x-coordinate of your vertex is negative b over 2a. That's the x-coordinate of your vertex. So we're saying x then is going to equal the opposite of b. Well, b is negative 6. The opposite of negative 6 is a positive 6. Over 2 times a. A is 1. So I get 6 over 2, which is 3. So I found the x-coordinate of the vertex. So it'll be 3. Now, if you were to graph this, which you will in another lesson, but if you were asked to graph this, since a is positive, that's a positive 1, your parabola is going to open up. All right, now let's find the y-coordinate. So the y is going to be f of 3. So wherever I see the variable x, I'm going to plug in 3. So I get x, which is 3 squared, put that in parentheses, minus 6 times 3 in parentheses, and then minus 2. So 3 squared is 9. A negative 6 times 3 is a negative 18, and then minus 2. So that 9 and negative 18 is a negative 9, minus 2, which is a negative 11. So your vertex is 3 minus 11, negative 11. All right, let's do one more, and I think that we'll be done with this. So number 11, suppose we had, suppose we had g of x is equal to negative 2x squared plus 8x. All right, let's suppose we had that. All right, so it's possible you could see something like that. So a is the coefficient of x squared, so that's negative 2. B is positive 8. And c is, since there's no c, remember that's understood to be 0. Okay? Because remember, let me write it here. G of x is negative 2x squared plus 8x and then plus 0. So c is 0. Don't forget that 0 there. All right, but in terms of the x-coordinate vertex, that's not needed, because if you look at the formula for the x-coordinate of your vertex, it's just negative b over 2a, so there's no c. Now, you're eventually going to have to use whatever c is. In this case, it's 0, but you're going to be using it when you find the y-coordinate. All right, so let's find the x-coordinate. So x will be the opposite of b. So if b is 8, the opposite of 8 is a negative 8, divided by 2 times a, so that's 2 times negative 2. So that's negative 8 divided by negative 4. A negative divided by negative is a positive, so that's a positive 2. So the x-coordinate vertex is going to be 2. Now let's find the y-coordinate. To find the y-coordinate, I'm going to find g of 2. So basically, find the y-coordinate where we see your variable x, you plug in 2. That's what that says. I'm going to plug in 2. All right, so I get g of 2 then will be negative 2 times 2 in parentheses squared. So negative 2 times 2 squared plus 8 times 2. All right, so 2 using the order of operations, I'm going to do exponents first. 2 times 2 is, remember 2 squared means 2 times 2, so that's 4. 4 times negative 2 is a negative 8. 8 times 2 is 16. And negative 8 plus 16 is a positive 8. So I get the vertex 2, 8. Okay? All right, so basically what we did in this lesson was that we found the vertex, and that's all they wanted you to do, was to find the vertex of a quadratic function. First of all, if it's given in standard form, and it's just hk, you just have to be careful when you have something like x plus 3. Because the vertex is not the x-coordinate is not a positive 3, because you remember you got to think about it as x minus h. And h would be negative 3 in this case. All right, so you have to be careful. All right, so that takes care of this lesson.